Hello, everyone, and welcome to Database Security Office Hours for March 2021. I'm Russ Lowenthal, Product Manager for Database Security, and this month's topic is Transparent Data Encryption. And you'll notice a subtitle, Back to Basics. We're going to go through some of the basic things you need to think about if you are using or deploying Transparent Data Encryption. Let's see, just a couple of housekeeping things before we get too far into it. The first one is obviously I do record these calls. You'll find the recordings on the Ask Tom website, usually within 2 or 3 days after the session is over. I have to send the recordings through for our video team to approve and everything, after which they're uploaded to YouTube and the website is updated with the information. We do these calls every month to give you just a way to continue your education around database security, another channel for you to ask questions besides the regular channels of the forums and Twitter and service requests, and just in general to make sure that we're keeping you up to date on developments around database security. If you have questions during the presentation, please enter those questions into the Q&A panel that you'll see at the bottom of your screen. We'll try and get to those at the end of the session. For announcements, this is a somewhat unique month. I actually have no announcements this month. Last month, you may remember, was fairly busy, but we're working very much towards several things that are going to be released in April. But for March, we're going to go directly into today's technical session, which is Transparent Data Encryption. And again, it's back to basics. Now, the reason it's back to basics is if you look at recent office hours sessions, last year, at the start of the year, we did 2 sessions on advanced use cases for transparent data encryption. And these were very in-depth, a lot of technical detail, but we didn't really cover, the basics of encryption during those. If you go back earlier this year, a couple of months ago, we did a session on the new version of Key Vault. And key management, of course, is intimately tied to transparent data encryption. But again, we didn't cover the basics. So several questions from the people who attend office hours later, we decided it would be a good idea to go ahead and cover some of those basics, and that's what we're going to do today. So we start with the most basic question of all: why would you encrypt in the first place? And really the reasons you encrypt, well, there's generally 2 of them. One of them is because you may have a regulatory requirement to encrypt your data. There are a lot of data protection regulations which recommend or require that data be encrypted. But another reason you would typically encrypt is to reduce the risk that data is stolen. And while there are a lot of things you can do in an Oracle database to try and keep someone from accessing data in an unauthorized fashion, we've talked about database vault, we've talked about things like label security, we talked about a lot of ways to control access, but none of those close this one hole that without encryption you can't hold. So if you can't close. So if you're not encrypting your data, then no matter what else you do, there is always a path that an attacker can take that bypasses your other security controls and gives them access to data. And that path is accessing the underlying storage of the Oracle database. If I'm an attacker and I gain access to the database server, I can log into the database and try and steal data that way, in which case controls like database vault will stop me, in which case audit capabilities like unified audit will tell you that someone has tried to do this. But if I'm a good attacker, I don't do that. Instead, what I do is I go against the underlying storage for the database. There was a case a couple of years ago where one of the states in the United States, their Department of Revenue, the people who manage taxation for the state, was hacked. And this is exactly what the attackers did. They never even logged into the database. What they did was they recognized they were on a database server and they exfiltrated the data files for the database right out from under the security group at the Department of Revenue. And then they were able to start up their database somewhere else, and every single person who'd ever paid taxes in that state suddenly had their data compromised. Cost millions of dollars to mitigate, really, really embarrassing for the state. Well, if you're not encrypting, that's the kind of attack you leave yourself open to. Other ways that you leave yourself open: backups. If you back up encrypted data, the backup is also encrypted. So if an attacker manages to gain access to your backups, it doesn't matter. Data pump exports, if you encrypt your data pump exports, again, the data is encrypted. If an attacker gains access to the exports, doesn't matter, that data is encrypted. So for all of these reasons, we encrypt our data to prevent the risk that someone goes around our database controls and steals the data directly from storage, all right? Now, I've been talking primarily in terms of encryption of data at rest, but it's important to remember that you also need to encrypt data in motion. Oracle database gives you two ways to do this. We're just going to cover them very briefly. One of them is native network encryption. Dead simple to turn on. It's one line in your SQLnet.org on the database server. No client changes required. No changes to application. Does a great job of encrypting. The other one is industry standard transport layer security. Here's where you issue a certificate to the database server. You make sure that the clients have the trusted root certificate that recognizes that certificate for the database, and you're off to the races, you're encrypted. Both of them will encrypt data in motion. No, what we're talking about in today's session is transparent data encryption, encrypting data at rest. Now, when you encrypt data at rest, you introduce additional challenges. And data at motion, pretty easy. You get it set up. You don't have to worry about persistently managing the keys. You do have to worry a little bit about performance impact if you're limited on bandwidth. But with TDE, there's all kinds of things, and that's what we're going to cover today is TDE. All right. Transparent data encryption, been around since Oracle 10G release 2. That's when we first released it. And every new version of the database, you'll see some change, usually multiple changes to TDE. We are constantly trying to improve this particular feature of the database. One of the reasons we put so much work into improving TDE is transparent data encryption is the #1 database option, #1 database security option that people deploy. There are tens of thousands of Oracle customers that use TDE and rely on it to reduce risk. So obviously we put a lot of effort into making sure that TDE is up to date. We fix any bugs, we keep performance, and we add new features as our customers request them. Over the years, transparent data encryption has become integrated with just about everything in the Oracle ecosystem. It works with RAC, it works with DataGuard, it works with Golden Gate, it works with ZDLRA, ASM, doesn't matter. TDE is integrated with just about everything in the Oracle stack. When you use transparent data encryption, you have two choices for how you're going to encrypt your data. You can encrypt data at the tablespace level, or you can encrypt data at the column level. Now, several times during today's presentation, I'm going to make this statement to you. So, you hear it once, maybe you forget it. You hear it twice, maybe you forget it, but hopefully I get it in at least 3 times. If you are evaluating your encryption options and you decide that the right way to go is column level encryption, think again. Almost all the time, the right option is tablespace encryption. Very, very few use cases are appropriate for column level encryption. If you think again and you still think it's column level encryption, maybe send me an email. Let's talk a little bit about your use case, because I would hate for you to go down the wrong path. As we go through today's presentation, you will see why tablespace encryption is almost 100% of the time, almost 100% of the time, the right answer. Doesn't mean column encryption should never be used. It just means most of the time, if you go down that path, you're choosing a suboptimal way to implement. All right, tablespace encryption, just like it sounds like, we encrypt the entire tablespace. That's every data file in the tablespace. Anything you put into that tablespace is encrypted because it's an encrypted tablespace. Column level encryption, we choose 1, 2, 3, however many columns we're going to choose within a table, and we alter those columns to be encrypted, or we create the table with encrypted columns in the first place and then put data into it. So entire table space, individual columns. Both column encryption and tablespace encryption have keys. The tablespace encryption key is unique for every tablespace, and every data file within the tablespace shares the same key. Column level encryption, the key is unique for every table, and all encrypted columns within a table share the same key. Default encryption algorithm for column level encryption is Advanced Encryption Standard AES 192-bit length. Default encryption for tablespace encryption is AES 128-bit length. Okay, moving on. Now, I'd mentioned keys. There are table keys and there are tablespace keys. These keys are stored inside of the database. Tablespace keys are visible in the control file. They're also in the the data file headers. Table keys are stored inside the data dictionary. Both table and tablespace keys are encrypted with another key that is outside of the database. We call this other key the database master encryption key, or MEK. If you're moving outside of Oracle terminology and you think in terms of pure cryptographic speak, the things that your security guys talk about, table and tablespace keys are data encrypting keys. That master key is a key encrypting key. So if you're looking at different standards that talk about keys, like maybe the PCI standards, you'll see references to key encrypting keys, the master encryption key, and data encrypting keys, table and tablespace keys. Your TDE master key is stored, as I've mentioned, outside of the database. That can either be in an Oracle wallet or it can be in Oracle Key Vault. If you store your master encryption key in an Oracle wallet, then that key is protected by a standard called PKCS12. It's basically an encrypted file that sits out on the operating system, and the encryption is done using a passphrase that you use when you create your wallet. The strength of your encryption is AES 256, and the key is the passphrase. So the stronger your key is, your passphrase is, the better your encryption is, right? Key Vault removes the encryption key from the database server and puts it into a key vault. If you've been coming to the office hours for a while, we've talked several times about Key Vault. You know that Key Vault allows you to have a multi-master cluster, all of them online at the same time, up to 16 nodes. It's specifically designed to work with TDE. It's basically the way you should probably be going when it comes to storing your keys, right? Key Vault works, of course, with Oracle TDE, but it also works with things like SQL Server and MongoDB and Golden Gate and ZDLRA. But all we care about today is transparent data encryption. With wallets, you are responsible for backing up the wallet. You are responsible for distributing the wallet if you need to make copies of your data. For example, if you have a data guard environment, you're going to be in charge of moving that wallet over to your standby servers. If you are making clones of the database, you're going to be responsible for managing that. With Key Vault, you don't have to distribute the wallet because databases just subscribe to the key within the wallet. All you have to do is grant them access to it. That can be a real advantage if you do a key rotation, if you change your key, because when you change your key, that new key is instantly available to every database that wants to subscribe to it. From a threat standpoint, you're better off not having your encryption keys on the same server as your encrypted data. Remember, the threat that we're trying to protect against is someone who's gained access to the storage for your database. If your key is sitting on a file on the same server that your database files are on, well, then an attacker just steals both the encrypted data files and the encryption key, and they're off to the races. Now, your key in the wallet is still protected. It's protected by that passphrase, but depending upon the strength of your passphrase, it may not take long for your attackers to manage to break that particular encryption. Like if you use my password, and my password is always Oracle 123, by the way, because Oracle is very secure. If Oracle 123 is your password for your wallet, those attackers are going to be into your wallet in about 2 shakes of a lamb's tail. It's not going to take them any time at all, okay? So if you are using a wallet, long, complex passphrase, you're key to being safe there, okay? Now, how do you move from an unencrypted state to an encrypted state? You've got TDE set up, you've created your master encryption key, and now you've created an encrypted tablespace, and now you're ready to begin encrypting data. Well, you've got a couple of choices here. One choice is to reorganize the data into an encrypted tablespace. This is just like any other data reorganization. You can do export, and then import into the new tablespace. You can do alter table move. You can do alter table move online. All you're going to do is reorg the data, and just by virtue of being moved into the encrypted tablespace, the data is encrypted. Your other choice is conversion. You're going to take your existing tablespace and you're going to convert it from its unencrypted state to an encrypted state. Here you have two choices. The first one is offline conversion. You're going to take the tablespace offline, and then you are going to convert to an offline key conversion or offline encryption conversion to an encrypted state. The other is online conversion. You're going to take the tablespace and you're going to convert it, but this time the syntax you're going to use is online. Okay, so online or offline. Now, as you probably can expect, there are advantages to offline, there are advantages to online. Okay? So it's not a case of you always want to use one or the other. My personal preference, if I am doing conversion for a tablespace, is offline conversion. If I can afford the downtime, in other words, if I can take that tablespace offline long enough to convert it, then that's what I'm going to do, because it is the easiest way to do the conversion, and the conversion happens much more quickly. We had a customer who had a 60 terabyte database, and they converted the entire database over the course of a weekend. Okay, so if you can afford a weekend's downtime, you can do a whole lot of data within a tablespace very, very quickly. Advantages of offline conversion: simplicity and speed. Now let's look at online conversion. The advantage is probably pretty obvious. I don't have to take the tablespace offline. That means I don't impact the availability of my database. But there is a downside to online tablespace encryption. And that downside is, during the time that I am converting from unencrypted to encrypted, I have two data files. I have my unencrypted data file and my encrypted data file. So to do online encryption, I have to have enough extra storage to double the size of the largest data file that I'm going to convert. There's another downside. While I'm doing that conversion, performance is impacted. It's not going to shut you down. It's not going to suck up all of the cycles for the database server, but it is definitely going to cause a little bit of a performance degradation. So if you are doing this, you kind of want to do it in a slow period, still maybe over a weekend or something. But again, you have two choices: offline conversion, online conversion. Okay. Now, we talked a little bit about performance. Encryption always induces overhead because you are asking the processors to do more work. You're asking them to do whatever they were doing before, plus the work involved in encrypting data as you insert or update the database, and decrypting data as you select it from the database. In most cases, the overhead for transparent data encryption is fairly low, especially if we're talking tablespace encryption. We usually figure for around 3 to 7% throughput delay. Okay, so response time delay of between 3 and 7% for OLTP workloads. And that is frequently a very safe estimate. If we are looking at transparent data encryption on Exadata, for example, we often can't measure any difference in the response time. I've had many customers tell me that they saw no difference at all. But there are always edge cases. There's never anything that's everybody, works perfectly for everybody. TDE is no exception for this. There are some use cases where when you encrypt the data, you induce enough additional performance degradation that it's noticeable, and it can be very noticeable. I've seen cases where under specific circumstances, TDE will cause 20, 25% performance degradation. These are use cases like I'm doing a lot of batch processing and I'm working with large objects, inserting maybe video files or scanned documents into the database. In those cases where I'm doing a lot of encrypt operations and I'm doing them very, very rapidly, TDE can cause things to go a little bit slower, okay? There's another place where you want to think about the impact of encryption, and that's in terms of storage. For tablespace encryption, The impact on storage is very low. It's an extra data block that gets chewed up to scribe for the metadata for the encryption. You know, for most of us, that's 8K for data files per data file. For some of you, if you have really large blocks, it could be 16K, but it's not a lot of space. Now, if you talk column level encryption, that equation can change, because with column level encryption, we are going to pad every column you encrypt with some additional data to handle the encryption information and to make sure that you can't just do analysis on the length of the column to figure out what the values are. That padding is going to increase the length of the column between 1 and 52 bytes. It'll include the padding, a salt for the encryption, and an optional message address, an integrity check. Now, that 52 bytes isn't that significant if we're talking about encrypting a 2K varchar file or a column, right? 52 bytes on top of 2K, not a huge deal. But if what we're encrypting is a column that has a 2 byte, you know, maybe on or off, or 3 bytes on or off, but a very small column, and you add 52 bytes to that, you can make that small column quite large, and you can see a significant change in your database storage consumption. Performance, again, impacted by your encryption target. And here, just like with storage, which type of encryption you're using really informs how much performance degradation you're going to see. Let's look at how encryption works for tablespace. With tablespace encryption, when I encrypt data and I write blocks down to disk, the encryption operation happens upon write. When I read blocks up from disk, the decryption operation happens upon read. That means that data blocks in the database buffer cache are decrypted. In most cases, greater than 90% of query activity is served by the database buffer cache. And what that means is greater than 90% of all query activity does not involve a decrypt operation. Just makes sense if you think about it that way. So the use of tablespace encryption benefits greatly from caching. Now let's look at column level encryption. With column level encryption, the decrypt operation happens as data is read within the buffer cache and sent to the program global area. Column encrypted data is encrypted inside the buffer cache, and that means every single select for that data incurs the overhead of the decrypt operations. Tablespace encryption. Because I am encrypting at the tablespace level, the encryption is completely invisible to things like indexes. It is completely invisible to the optimizer. We don't care that it's encrypted because it's a very predictable workload. If it's column level encryption, this is not the case. With column level encryption, indexes change. Normally, if you look at the leaf rows in an index, the leaf rows in an index are in sorted order based upon the values within the column you are indexing. If you encrypt that column, the index values are also encrypted. They match the encrypted value that's in the table. And suddenly what you see is the leaf rows of your index are no longer in sorted order based upon the original data. They're now in sorted order based upon the encrypted data. Sometimes this matters, sometimes it doesn't. If you are using equality predicates in your queries, in other words, if I'm saying I want to select star from employees where first name equals Russ, and Russ is an encrypted column. Well, in the index, Russ is encrypted. I simply encrypt Russ in my query. I go look for that encrypted value in the index, and I'm able to use it. But suppose what I do is I say, I want to select star from employees where first name like Russ %, because my first name is actually Russell, and that's probably what's in the employee table. Okay. Well, in this case, I can't just look for Russ. I have to do a range scan to try and find that value. But my data in the index is no longer in sorted order. And so what happens is the optimizer ignores the index for this range scan operation, and you fall back on full table scans. Now, changing from an index range scan to a full table scan can be a very significant impact on performance, much more significant than the impact of encrypt and decrypt operations, because now you're looking at a whole lot of data here. So again, if you find yourself thinking column level encryption is the right way to go, think about what I've just told you. How is your data being accessed? Are you doing index range scans? If you are, you might want to take a look at tablespace encryption. We move on, okay? Oh, wait, did I skip something? Oh, yeah, so this is kind of obvious. Tablespace encryption, the performance impact is fairly consistent, right? 1%, 2%, 3%. You can talk about it in those terms. Column level encryption, the performance impact is wildly variable, wildly variable. It can be 1% for certain queries. It can be 5,000% for other queries. It all depends upon the execution plan, okay? Now we move on. Tuning transparent data encryption. If you decide you're going to use column encryption, and again, if you do that, click again, but if that's the choice you make, then your best way to ensure good performance is to encrypt only the columns you have to encrypt. That's one of the benefits of column level encryption. You're shrinking what has to be encrypted and decrypted. Remember when we were talking about padding, I had mentioned that we have padding, we have a salt, and we have a message address that's set up. If you don't need that MAC, turn off the integrity checking. The database does integrity checking out of the box. TDE gives you a cryptographically secure message address. So it is a better message address. It's more prevention against tampering. But if you don't need that, turning it off will definitely improve your performance. Don't forget, after you encrypt a column, you need to rebuild your indexes, because again, you've changed the sort order for the data. All right, so that's column level encryption. For tablespace level encryption, remember, the buffer cache is your friend here. Make sure you've got your SGA size set appropriately. The more blocks you serve up from your buffer cache, the more decrypt operations you skip altogether, and the better your performance is going to be. Consider using advanced compression to compress your data. If your data is compressed, it is stored in fewer blocks, which means you are reading fewer blocks, which means you are decrypting fewer blocks. So again, improves your performance. Tablespace encryption takes advantage of reduced instruction sets built into most modern processors. If you are running on a server that has an Intel processor or an AMD processor, then inside of that processor, unless your hardware is really, really old, are reduced instruction sets that handle encrypt and decrypt operations for AES. That's the most common encryption standard. Make sure that you're using those. It's possible to disable those reduced instruction sets in BIOS on some servers. It's also possible, if you're using a virtualization layer for your database, that your virtualization layer is not configured to pass on those reduced instruction set flags to the database. Make sure you've got that working. If you're running on Exadata, make sure you've got Smart Scan turned on, because then the decryption operations happen down in the storage cells, okay? Let's go back to hardware and software acceleration, crypto acceleration. I had mentioned Intel and Spark. There's a third type of processor that we frequently see used with Oracle, and that is the IBM Power PCs. Now, much like Intel and Spark, those Power PCs, good chips, they have got reduced instruction sets built into them for encrypt and decrypt operations. But as you might imagine, just like Oracle has optimized Spark for running Oracle workloads, IBM has optimized those Power PCs for running things like DB2. Oracle database cannot use the reduced instruction sets that are built into the Power PC. And so all encrypt and decrypt operations happen on main CPU. So your overhead on AIX, which is usually where you're going to find those Power PCs, is going to be a bit higher than it is on Intel or Spark, okay? we move on from there. Backups of the database are often neglected in planning. As people are thinking about moving to TDE, it is very common to kind of forget about backups here. And depending upon your backup storage, this can be a real mistake. If you're using modern backup storage, things like a data domain or like CDLRA or most of the virtual tape drives, then you are probably taking advantage of technologies that shrink the footprint of what you put onto that storage. And there are 3 technologies that modern storage uses to shrink the footprint of storage. One of them is called thin provisioning. And this one is really, really simple. Thin provisioning just says, I can have multiple servers subscribing to my storage. And maybe I tell this server you've got a terabyte, and I tell that server you've got a terabyte, and I tell this other server you've got a terabyte. So I can have, 40 terabytes allocated to different servers. But that doesn't mean there's 40 terabytes available in the storage array, because most storage arrays assume that servers won't consume 100% of their data space, at least not right away. And so they thin provision those, and then they allocate from a central pool. Okay, so that's one way to reduce storage use. Another way we reduce storage use is with deduplication. If I take a database backup today, and then tomorrow I take another database backup, how much data has actually changed between today's backup and yesterday's backup? Usually not a lot, 1%, 2%. I think the average is we expect around 10% change per week in a database. So what storage arrays will often do is they will use deduplication. I see a data block, I see a backup of that data block, it's the exact same block, I don't write it again, instead I just record a pointer to it. This file has that data block, that other file has this data block. And so I get very high rates of shrinkage using deduplication. 45 to 1 is generally the average we look at in most storage. So what would take 45 terabytes takes 1 terabyte. That's pretty common, okay? The third technology we use is compression, and we're all familiar with compression. This is things like WinZip or GunZip or something like this, where you're compacting the bits and you're storing them in such a way that you shrink the size of a file. And in most cases, compression buys you about a 2 to 1 improvement for database backups. So 3 types of storage. Now, in a TDE world, thin provisioning is not impacted at all, okay? Compression generally goes away. You can compress encrypted data a little bit, but the data is randomized. It just doesn't compress well. Compression algorithms don't work well against encrypted data. So you'll see your benefit from compression fall from about 2 to 1 to about 1.1 to 1. We usually just say compression goes away. Deduplication isn't impacted. A data block is still a data block. It doesn't matter that this data block is unencrypted and this data block is encrypted. If I write that data block multiple times, then as long as the storage media understands Oracle block sizes, most of them do, then you'll still be able to take full advantage of deduplication. Except when you initially encrypt your table space, every block in that table space is changed. Every single block goes from unencrypted to encrypted. When you do your next backup, your storage array sees, wait a minute, every single block has changed. I can't deduplicate because I don't already have this block. And so what it looks like as you're watching your backups age out is kind of like a snake that has eaten something very large. You've got your unencrypted database backups. You've now got your encrypted database backups. And as the unencrypted database backups age out, move down the snake, you've got this big glut that's going through there. And for a while, it looks like you have 2 copies of the database. The copy from before you encrypted, the copy from after you encrypted. Okay, makes sense? Now, the compression issue is solvable. If you have advanced compression compresses within the data block before the encrypt operation occurs. Advanced compression generally gives you better compression ratios than you got from your storage array, usually around 2.2 to 1. So you can overcome the increase in storage requirements for backups by using advanced compression. And as I'd already mentioned, advanced compression reduces the amount of I/O you have to do, so it also improves your performance from a encrypt and decrypt standpoint, okay? Just some basic recommendations. Just some basic recommendations if you're doing TDE or getting ready to implement TDE. Third time I've said this. When in doubt, tablespace encryption is what you should use. If you do no analysis, if you do no thinking about it, don't look at column encryption, do tablespace encryption. If you find yourself leaning towards column encryption, think again. If you think again and you still want to use column encryption, double check your use case. Check with whoever your Oracle account team is. Feel free to send me an email. There are cases where column encryption is the right choice, but they're rare, okay? Before you get too far down the TDE path, think about key management. Encryption is actually really easy. You turn it on, you make sure it's not going to cause performance issues, and that's it. It's transparent. It's really easy to work with, okay? Key distribution is what you've got to worry about. How do you keep those keys safe? How do you make sure that your racked instances all have access to the same key, that your data guard instances all have access to the same key? With a wallet, that work is on you. With Key Vault, that work is on the Key Vault. It's much better to put it on the Key Vault. I had a case just earlier today where someone asked me the question, I've lost my encryption wallet. How do I recover my data? I was very sorry to have to tell the customer, you can't recover your data. If you've truly lost your wallet, there is no backdoor for encryption. There is no way to decrypt that data without that encryption key. Maybe you could hire the NSA to do it, but no normal person is going to be able to decrypt your data. All right, test your system under load, okay? Most of the time, TDE's performance impact is negligible. You're not even going to notice it, or if you do notice it, it's going to be very, very minor. But remember those edge cases. If you don't test, I can almost guarantee you're going to be one of those edge cases. If you do test, there's a pretty good chance you're not. So test bulk inserts, test your batch processes, test everything you do before you move TDE to production, okay? I've had cases where you're running on older hardware. You test, it doesn't work. Okay, we're going to make the change to TDE when we up platform, when we change our platform with more modern hardware that has faster CPUs. Okay, test before you encrypt. Use advanced compression. If you have access to advanced compression, use it. It's going to reduce your storage cost. It's going to improve your performance. Don't forget whoever is managing your backup arrays, all right? If you're working with data domain, if you're working with CDL array, talk to whoever is managing those before you encrypt. Let them know, this is what I'm getting ready to do. Here's what you're going to see when I encrypt. It's going to look like new data coming into you. Deduplication is going to fall away. Compression is going to fall away. Plan to make sure you have enough storage. TDE, especially in later versions of the Oracle database, has gotten really, really easy to implement, all right? We've had customers that have gone out and encrypted 50, 60 databases over a week. Well, that's fine. They're all up and running. They're now encrypted. Now it comes time to do their weekly level 0 backups. And all of a sudden, their storage arrays are saying, hey, wait a minute, I'm out of storage. Talk to your backup storage manager. Map out which databases you're going to be encrypting. You may need to stagger those. You may need to do a couple this week, a couple next week, a couple the week after. Not because it takes that much time to encrypt them, but because you want to make sure you don't overrun your storage allocation, okay? That's really it for transparent data encryption. I hope I haven't scared you away. One of the downsides of being a product manager is we get all of the horror stories, right? There are tens of thousands of Oracle customers using TDE. It is the most used option, all right, for security. It is as error-free as we can make it. It is as trouble-free as we can make it. If you keep in mind the basics that we've talked about on this call, the basics, plan for key management, test for your performance, plan for how your storage is going to be impacted, you're going to implement TDE and have no problems at all. And with that, before we get to Q&A, because I know I usually lose a lot of people for Q&A, next month, office hours is Wednesday, the 14th of the month. It's the latest it can possibly be in April. The topic is, at least the tentative topic is data safe. We are adding in a new feature for audit data lifecycle management. I'm very excited about this new feature, by the way. It really brings a lot of very useful capability to data safe. All of you who are using data safe, I think you're going to be impressed with it. I just today got a chance to go over what the screens are going to look like with the UI team. Really enthused about this, and I can't wait to show it to you next month. But that's what we're looking at this month. For this month, you'll see the recording up on the Ask Tom website, usually within a couple of days here. All right, now let's see questions.